Physicists just heard something inside a superconductor that shouldn't exist. A quantum echo. It's like the material remembers a jolt of light and answers back. Late. If scientists can control it, this could change quantum computing and sensing. Let's unpack the echo that's freaking out the physics world. Welcome back to Future Gen News, your home for the biggest breakthroughs in quantum tech. Today, we're breaking down the new quantum echo discovered in superconductors. What it is, how it was found, and why it could become a new control knob for quantum devices. If you love future-proof science with real-world impact, subscribe and hit the bell. Researchers at the U.S. Department of Energy's Ames National Laboratory and Iowa State University zapped a thin film of niobium, a workhorse material in quantum circuits, with carefully timed terahertz (THZ) light pulses at about 4 Kelvin. After the initial response, they detected a delayed, faint signal, a quantum echo, tied to the material's Higgs mode. That's the amplitude breathing of the superconducting order parameter. In plain English, the superconductor was nudged, stored coherence, and then spoke back later. In familiar echo effects, like spin echoes or photon echoes, you can often explain the delay with simple rephasing of many slightly different oscillators. Here, the team saw signatures that don't fit the usual script. Asymmetric echo delays, and even negative time echo signals where the material seems to build a response before the last pulse. That bizarre timing points to anharmonic coupling between the Higgs mode and quasiparticles, the electron-like excitations that appear when superconductivity breaks down. The trick was a 2-pulse THZ sequence. Think of it as ABB versus BAA timing that writes a temporal Higgs grating into the superconductor. That grating stores phase information. Then the system rephases and emits an echo at frequencies tied to the superconducting gap. Crucially, this separates Higgs mode pathways from the noisy background, letting the team see the hidden dynamics. Because echoes are handles, if you can write, store, and read out coherence on demand, you have the beginnings of quantum memory and precision sensing. The Ames team says the Higgs echo lets them encode, store, and retrieve quantum information in niobium, the same material used in many superconducting qubits and resonators. That's a real path toward better qubit diagnostics, materials benchmarking, and possibly noise-resilient control. Echo physics isn't new. In 2024, scientists reported Josephson plasmon echoes in cuprate superconductors, but this new work is different. It's an unconventional echo of the Higgs mode in niobium, the backbone of today's superconducting tech. That moves echoes from exotic materials toward mainstream quantum hardware. And it exposes quantum pathways we couldn't resolve before. So what's the bottom line? Researchers didn't just find a quirky blip. They opened a new window into how superconductors store and reveal quantum information. If the Higgs echo can be engineered and scaled, it could sharpen our quantum sensors, improve qubit control, and even inspire new memory elements. If this breakdown helped, like the video, share it with a science friend, and subscribe for more weekly deep dives into quantum tech.